graph data today using graphical analysis. On your Chromebook, the easiest way to get to that is to click on your launcher button. It may appear down here. If it doesn't, you can simply search for graphical analysis and it will pop up. When it loads, there's a couple of different ways to use it. Today, we are going to be using the manual entry. So we're going to be taking our data from our battery-powered vehicle lab and putting it into graphical analysis. This is similar to simply graphing by hand. First thing that we're going to want to do is to label our columns. So over here on the right-hand side, click on the dripping dots in the data table and click on column options. So we know this will be graphed on our x-axis, which is our independent variable. And in this case, it was time with the unit of seconds. Down here, this information is useful for us later. Today, we're not going to use it, so I'll teach you how to use that later. We're going to do that same thing in the y-axis, which was our dependent variable, which was distance. And its unit I used was centimeters. You may have used meters or maybe even inches. From here, there's two other things that you need to do. One is to put a title on your graph. To title your graph, you will come down to this button down here. This is your menu option for your graph tools. And you're going to go to Edit Graph Options. And you can change the scale, which we'll do later, but what we're going to do right now is to title our graph. So to do that, we will insert an appropriate title or maybe effect of time on distance of buggy. Your title should have both the independent and dependent variable listed within it. Lastly, you're going to want to save your work. This menu button here will give you that option. So if you click on that file menu, you can go File, Save As, and then you can save it in the folder you feel is appropriate, again, with the title you feel will be helpful for you in finding it. Okay, you're going to enter your data. Your time will obviously be each of your independent variable values for your time. You might have used 2, 4, 6, 8, 5, 10, 15, 20. And then over here, you're going to put in your average distance. So for instance, my first data point was for 2 seconds, and the distance that the buggy was at was 42 centimeters. You will continue to enter your data, and you'll notice when you click on that next line that a point shows up on your graph. You'll continue to do that for all of your data points. I have entered all of my data, the time and the distance where the buggy was at each of those time intervals. And I want to look more specifically at my graph. And if you look at the corner here, you're going to notice that our axis starts at 100 centimeters and 2 seconds. And I don't want that. What I want to do is I want to have a good idea of 0 time and 0 seconds. So I'm going to come down here and click on my graph options again. And on my x-axis, I want that number to also be 0. Or you can use this automatic scaling and you could put in here always show 0. You can also do that for your y-axis, which again says always show 0. And then that should show you this point here in both the x and the y directions to be 0. If we look very closely at our data, we notice that the data is fairly linear, meaning for each time interval, the distance increases by a set amount. And in order to put an equation on this data, we are going to use something called a curve fit. Just because it says curve fit doesn't necessarily mean we have to put a curve. A curve can also represent a line. Essentially, what we're going to be asking the computer to do is to put an equation with our data. To do that, we can choose a different fit. In this case, we are going to choose the default, which is the linear fit, but there are many others to choose from for other situations. When we click Apply, this box will come up to give us information about our equation. Notice it's in the slope-intercept form of y equals mx plus b, where m is the slope, which is given to you the value here of 34.7, and then b is the y-intercept. So if I come down here in my graph, you're going to notice that right here isn't at 0. It's a little bit above 0, and we can actually see that value here given in our table, which is 5.8.